In this video, you will learn how to find x and y intercepts from a graph, table, and equation, as well as learning what an intercept is. You want to attach this notes paper to the next right-hand page in your interactive student notebook. In order to make it fit, you might want to cut off the top border as well as the right-hand border, but make sure that you leave the bottom so that you can fill out the examples. As I go through each section, you want to write the notes right onto your notes paper so that you have the notes for class tomorrow. When you hear the word intercept, you might be thinking of some familiar times that you hear words like interception. An interception in football is when a player catches a ball that was thrown by another team. And another definition for interception would be when someone intercepts or receives a transmission, such as a phone call, from someone they weren't supposed to. You may see that in movies. But in math class, an x-intercept is the x-coordinate of a point where the graph crosses the x-axis, and a y-intercept is the y-coordinate of a point where the graph crosses the y-axis. In other words, we look at the points where the graphs cross each of the two axes. First, let's look at the x-intercepts. In other words, the x-coordinate of a point where the graph crosses the x-axis. So we need to identify the point in which each graph crosses the x-axis. So in the first one, I see that the graph crosses the x-axis at -2. So my x-intercept is -2, and we write it as -2, 0, because I went to the left 2, and I didn't go up or down at all. In the next graph, my x-axis is crossed at +2. So the point at which the graph crosses the x-axis is 2, 0. And in my third graph, the graph crosses the x-axis at the point 6, 0. So my x-intercept is 6, and the point is 6, 0. You may be starting to see a pattern here, and we want to see if a pattern continues. So now let's look at the y-intercepts. The y-intercept is the y-coordinate of the point where the graph crosses the y-axis. Our first equation crosses the y-axis at 4. So the y-coordinate of the point where it crosses the y-axis, in other words, the intercept is 4, and our point is 0, 4, because we don't go to the left or right at all, but we do go up 4. In the next graph, we see that our line, or the graph of our equation, crosses the y-axis at 6. So our point for our y-intercept is 0, 6. And in our final graph, we see that the line crosses the y-axis at 0, -3. Pause the video and see if you can write down the pattern that you notice. You've got it. All the y-intercepts have an x-coordinate of 0, because we can look at each blue dot above, and we see that since we don't go to the left or right at all, our x value has to be 0. And all x-intercepts in orange have a y-coordinate of 0, because even though we go to the left or right, we don't go up or down at all. We can use this now to help us find our intercepts both in tables, which is very quick, and in equations, so we don't have to graph. I know you're probably wondering, why do we care? But it'll make it much faster for us to graph if we're able to use the intercepts. And when we do word problems, the intercepts usually have important meaning. So just wait. Keeping these two facts in mind, it should be easy for us to find the intercepts for the equation y equals -2x plus 2 using the table. I've already put some of the points in, and we always want to look for zeros when we're looking for intercepts. So I see 0, 2, and 1, 0. And I want to be careful which is the x-intercept and which is the y-intercept. So looking at our facts above, we know that all y-intercepts have an x-coordinate of 0. And if I were to picture my coordinate plane, I know that my y-intercept will be somewhere along this y-axis, so I know that I'm not going to the left or right at all, so my x value will be 0. That means that the point 0, 2 is actually my y-intercept, because I don't go to the left or right, but I go up 2 in order to graph that point. Now let's look at the other point that has a 0 in it. So we have 1, 0. I know that all x-intercepts have a y-coordinate of 0, so I'll write this in for my x-intercept. And I always want to practice graphing it just to be sure. So the point 1, 0 means I go to the right one and I don't go up or down at all. That's on the x-axis, so that's good news. As a little preview to going ahead, once I find my two intercepts, I can graph the line right from there. You might have noticed how fast it is to find the intercepts in a table of values. Just always be careful which is the x-intercept and which is the y-intercept, because it's very easy to confuse them. If it's an x-intercept, it needs a value for x, and if it's a y-intercept, it needs a value for y that's not 0. Unless, of course, we go through the origin. Yay. Finally, we want to find the x and y intercepts for two equations when we're not given a graph or a table. Sometimes it's hard to read from the graph, and it's not actually at an integer, and sometimes we just don't want to go through the hassle of making a table. So I'll keep these facts in mind one more time. If the x-intercepts have a y-coordinate of 0, they're of the form sum x and then 0. And our y-intercepts are of the form 0 and then sum y. So in order to find the x-intercept, I leave x, but I know that my y value is going to be 0. So I rewrote my equation, but instead of y, I put 0, and now I solve for x. And I get 3. So if x equals 3, and I want to write this as a point, then my x-intercept is 3, 0. And you guessed it, if I'm looking for my y-intercept, I substitute 0 in for x. So I have y equals negative 3 times 0 plus 9, which means that y equals 9. It was so much faster for the y-intercept because I had already isolated y. Now if you wanted to, you could isolate x and then substitute in your 0 for y when you're looking for your x-intercept. That would be some extra practice with literal equations, but it's up to you. And we of course want to write this as a point, so our y-intercept is 0, 9. We could plot 3, 0 and 0, 9 and make a very quick sketch of the graph. I call it a sketch because it's usually not very exact, but we do only need 2 points to connect a line. Last one, almost done. To find our x-intercept, we substitute in 0 for y, and to find our y-intercept, we substitute in 0 for x. So let's do that and solve for our intercepts. If you want, you can pause the video and try it on your own. If you'd rather, you can wait and then watch when I do it. So x equals 5 over 3, or 1 2/3. So our x-intercept is 5 over 3, 0. If we were to look at a graph, it would have been very difficult to read the exact x-intercept on the graph, which is why solving the equation is so helpful. To do the y-intercept, we rewrite our equation with 0 for x, and we get y equals 5. So our y-intercept is 0, 5. Now I could graph this, and I know that my 0, 5 for my y-intercept will be pretty easy, but to get exact at 1 2/3 will be difficult. So again, that's why we call this a sketch, and it's not an exact graph, particularly when we have a fractional intercept. You may have noticed a few stray marks. For example, this parentheses, and up here in some places there was a coordinate. Unfortunately, the software is a little bit glitchy, so I hope that you're able to follow anyway. This concludes the video. You now should understand what an intercept is. You should be able to read the x and y intercepts from a graph. You should be able to find the x and y intercepts very quickly from a table. And you should be able to substitute 0 in for x or y to find the intercepts. Keep in mind that since the graph of a line is the collection of every single solution to that equation, we know that intercepts, just like any other points, are solutions to the equation, which is why we get a true statement when we substitute in our x value and y value for our ordered pair. Interception!